this question was emailed in from Ed, and this actually is kind of a refreshingly new type of question here. And what Ed's looking to do is identify, as we can see, this is on a range chart here. So he wants to identify when these range bars when these range bars consolidate for 3 bars in a row here. And he kind of circled them. Although this middle one here actually doesn't meet the requirements that Ed had written about here. So the last bar here actually breaks out of the consolidation area here. So it doesn't look like it qualifies here. But the first one and the second one here circled do. Right? So the way this consolidation works here is you take the first bar and you take the high price and the low price, right? And it creates a ranged area. And then you want to add like a little, what would you call it? Not a buffer, an extended range to it, right? So you would take the high price and the low price. And for today's example, we're going to say we're going to create an additional 5-tick range expansion area here, right? So you take the high of the first bar and add 5 ticks to it, right? And so that would give you the upper maximum range area. And then you would take the low price and subtract 5 ticks, right? And that would give you the lower range area here. And so to identify a consolidation, you want the body of the next 2 bars to lie within that upper range area and the lower range area. And remember, this is a 25 tick range bar here. So the second one here, just kind of eyeballing it, we can see the second bar, does fall within that expanded 5 tick range area of the first bar. But the third bar here, to me it looks like that low is definitely more than 5 ticks outside the lower range, created by the first bar there. So so just eyeballing it, I don't think that second one qualifies. But if we take a look at the third one here, right? So here's our first bar. So we go 5 ticks above that, right? And the second bar, the body of the second bar, definitely, it looks like it equals. So that's within that's below the upper range. And the third bar here also definitely looks like it's within it's below the, upper range area here. And clearly both the second and third bar are above the lower range area here created by the first bar, right? And so as long as, the second and third bar are within this range area, then we'll generate a signal on the third bar there, right? So that's it in a nutshell. And the first thing we need to do here is find an area or find some areas that qualify. All right, yeah, so there's an area, right? And here's a bunch of bars consolidating as well. And there's a bunch of bars consolidating, more than 3. We have 4 there. And let's see, we have 3 there, and we have 4 here, it looks like. Yeah. Let's just take that one off there. All right, so let's get BloodHound open here. So first thing we want to do, all right, is put a file name into BloodHound so we can start saving our work here. So you'll notice we also changed the change button to a save and a save as. So that's kind of a change that I felt was much more beneficial. So finally got around to doing it. So We can just hit the save button there. Actually, I guess not. Maybe the save as button. Okay. So anyways, this interface, it's about to become outdated. So, all right. So let's put in today's date. All right. So there's our file name for today. Got that in. So next, let's switch over to the Logic tab here. And let's create a new Logic template here. And let's rename this. Okay, so we're looking for, 3 consolidation range bars there. So let's see. All right, so the first thing we need is a bar direction. Right, we're going to need a bar direction here because, when we're looking at our, when we're finding these consolidation bars, the signal direction is defined by the first bar here. So there's the first bar, and it's a down bar, right? So the signal that we expect, or the signal that will be generated, will be a short signal here. So the bar direction is basically going to be establishing the signal direction, right? So we can see that, on the first bar here, right, we have a short output. All right, next, on the second bar here, now we need to verify, right, that the high of the bar is below the upper range. And I guess let's get rid of that. All right, there we go. So now I have a line, that's 5 ticks above the high of the first bar. So we'll do the same thing again here. There we go. All right, so now I've got some nice lines here identifying that expanded kind of range area set by the first bar. Right, so we want to make sure, right, that the high, the body high, all right, or the body top, the top of the body is below, right, the upper range, and the lower body is above the lower range. So to do that, we are going to use a comparison solver. All right. Yeah. So both of our input types, so input A, we're going to set that to price, right, because we're comparing prices, right? We're comparing the upper body, or the body top, right, to the high of the first bar plus 5 ticks, and we're taking the body bottom and comparing it to the low of the first bar minus 5 ticks. Right? So both input A and input B are going to be price types. All right, let's see here. So, so if the upper body is, if the body top is below, we're going to generate a long signal. And if the body bottom is above the lower range, then we're going to generate a short signal. Right? So for the long type, we're going to use the body top. So here's those 3 new price types that were just added with this new update here. So we're going to choose the body top, and for the short output, we're going to choose the body bottom. And what we're comparing that to, right, is 1 bar back. So our look back period needs to be set to 2. Right, so that's how we get the price data looking back 1 bar. So for the long, we're using the high of the bar, and for the short, we're using the low of the bar. Right, so as I said, so on the second bar, if the body top is below, right, the upper range, then we're going to generate a long signal. And if the body bottom is above, then we're going to generate a short signal, right? So we're expecting to see a long and a short signal together, when the second bar does meet those requirements, right? If the body of the second bar is inside this range, then we're going to expect to see a long and a short signal together on the same bar there, right? So now we need to check our outputs. And so basically the body top needs to be below, right, the bar number 1's high, right? So here it's backwards. A is greater than B. So we don't actually want A greater than B. We want, actually, I'm sorry. We do want, I got that backwards, didn't I? Okay, yeah, let's put that back. That's actually what we do want here. Yeah. And let's see. So the reason why we don't have a long output so far, and let's just focus on the bar on the output we're looking at right there. So the reason why is that I don't have this additional 5-tick expansion area added to the solver yet, right? So I need to use this difference amount right there and put in 5 ticks, right? So there. Now if we look at the description here, right, and sometimes it doesn't update. On some computers it will update instantly, some don't. So if it doesn't update for you, right, because right now you can see it says A greater than B by 0 ticks, but I put 5 ticks in here. So what you can do is just click off and then click back on the solver. And now when we read the description in here, it says A greater than B by 5 ticks or more. So yeah, so we want that. So oh, you know what? I'm sorry. I was right the first time. Okay. Let me back this up here. So we do want A less than B. So there we go. All right. Let's see. Okay, yeah, we're not getting a long output on this area yet. So, and that's because what we also need is the A equals B within 5 ticks. So, right, once we do that, once we use the A equals B within 5 ticks, that is what creates this additional 5-tick range area. There. Right, now since we reversed the long output section, we also need to reverse the short output section. Like so. There. And so there we go. So now on the second bar here, we have a long and a short output. Right. And we can see that actually that this happens a lot, right? If we look at, if we look at this, if we analyze what's going on, right? So here's a bar that has a long and a short output, and if we look up, well, yeah, look at the body of this bar, and it's definitely within that 5-tick upper range and 5-tick lower range, excuse me, there. So, and then if we look at the next bar over, apparently same thing. So yeah, so right, if we take the high and then add 5 ticks, right, the body is within that range, and the low of the body is above the lower range here. So if we take the low and go down 5 ticks, right, so this one falls in, and even this one here, right, the upper body is below the upper 5-tick range, right about there, right? And since that's a small body, obviously it's above that, right? So we can see that, basically this happens a lot all the time. So, but the key is, to get 3 bars this way, right? So we've identified the second bar, and in just a moment we can move on and take a look at the third bar there. But what we do need to do is we need to get rid of these outputs here that are long only or short only, right? Because all that we're interested in is when we have a long and a short together. So to do that, we can use a long-short modifier. Plug that in. And the mode that we're going to use is product. Right? Product is multiplication. So, all right. And so now we can see, right, that when there was a long only or a short only, that's been stripped out. So now we can see, right, when a bar is within that 5-tick range of the previous bar. So that's what we've identified so far. So let's see here. Before we get going too far, let's name this here. Okay. So now I think we're ready to move on to the third bar here. So what we can do is, to save ourselves some time, is we can make a copy of the second bar. So let's go over to the Solvers tab there, and we're going to select, right, that comparison solver here, labeled the second bar. We'll make a copy of it. There we go. We have a copy of it. And so now we can change the name. So this comparison solver will be used for the third bar. And the only thing we need to do is just change the look back period, right, to 3. That's it, right? Because if we're if we're looking at this bar, instead of looking back 1 bar, we need to look back 2 bars, right? So that's all we needed to do, right, to get the high and the low of bar number 1 when we're on bar number 3. Is we just need to increase our look back period. So, all right, so now let's go back to the logic board, and we'll go to the solver nodes, and in existing nodes, right, there's that number 3 bar. So we can add that to the board, and let's connect that up there, and let's take a look. Right, and there we go. Yeah, so we can see that there is a long and a short for that third bar. So that's good. All right. So we're going to, and again, we need to strip out the short only and the long only outputs, right? We need to strip out the output from those bars. So again, we're going to grab another long short modifier, plug that in there, like so. Change the mode to product. We'll rename this so we know what the long short modifier is set to, and there we have it. All right, now if we look at some of these other outputs, like let's look at this bar here, right? Why is there an output on this bar? Well, remember, you need to look back, look back 2 extra bars, and look at that range that's been created there, right? So the body of this bar definitely falls within the range, created by this bar that's, 2 bars back. Right? And then so on and so forth. Right? So same thing with this bar, right? The body of this bar definitely falls within the range created by this up bar. Right? And that's all these two comparison solvers are doing, right? Is they're just checking the body of a bar and making sure it falls within the range of either 1 bar back or 2 bars back, right? So now we need to start combining these elements together here. So remember, we start with a bar direction, right? And when we get to the second bar, right, the second bar is always going to be in the opposite direction. So what we're going to need is, let's see here. Yeah, let me grab another bar direction. So what we're going to need is a bar direction combined, right, with the bar number 2 solvers here. Because what might happen, if we don't make sure that bar number 1 is in the opposite direction of bar number 2, which is in the opposite direction of bar number 3, what happened is we might get signals on this type of scenario, right, where the bar directions are not reversing, right? Obviously this would be incorrect. So because the third bar needs to be an up bar, but it's not. Right, we got 2 down bars, but it needs to be up bar, down bar, up bar, right? So we need to check the bar direction of, bar 1, bar 2, and bar number 3, so that we don't get signals, on this, on situations like this. So for bar number 2 here, we're going to take a bar direction solver plus a look back modifier, and if we connect that up, and with the look back modifier, we're actually going to use the swap mode there. And so, right, so we're basically reversing the bar directions output, right? So on all these up bars, right, we now get a short output. So, going back to, where we're going to generate a signal here, right? The first bar is a down bar, and the second bar is an up bar, but we need that up bar to generate a short signal, because that's what we're going to be generating, is a short signal. So, but also, reversing this bar direction confirms that this is an up bar, and we reversed it into a short. So now I can take an AND node and combine those together, and there we have it. So we do have, right, a short signal on the second bar. Now on the third bar, why do we have a long signal? Well, because the system's not finished yet, right? But but remember, we're only looking at the rule here for bar number 2. So if this is bar number 2, right, that would be bar number 1. And that's only because we only have one specific component of the system that we're looking at, right? Once we hook in bar number 3, right, the solvers for bar number 3, then everything is going to start to get cleared up. So for now, we basically just ignore, right, the long output here on bar number 3. So the next thing we need to do is, remember, our signal is going to be here where I put the red arrow. So we need to get this short output from bar number 2 and push it over onto bar number 3. Right? So we need to take this short output from here and push it over onto bar number 3. And the way we can do that is with the look back node. So if we take a look at that, and what we're using is the displacement component here, right? So the displacement is set to 1 by default, and that's what we want to use here. And so I'm going to rename this to a short version of displacement and how many bars, number 1, just to let me know that I'm using the displacement function. So I'm not using the look back function, right? That's left at 1. So now, right, if we look over here, right, now there's no signal on bar number 2. But on bar number 3, we have that short output because we took the output from bar number 2 and moved it forward onto bar number 3. And so now we can hook in the solver for bar number 3. Right. So if we just look at this, right, there we go. Bar number 3 has both a long and a short output. So it's ready to go. So what I need to do is grab another AND node here. And yeah, there we have it. So there is our short signal there on bar number 3. And apparently we had some other consolidations. We got a lot of these patterns showing up here. So here we go. So there, oh, you know what? Oh yeah, look at that. Yeah. So let me put this back on here. So if we look at this, right, we have an up bar and then a down bar, but we also have another down bar. So I can tell, right, that this long signal is incorrect because this is not an up bar. It's a down bar, right? So we have up bar, down bar, and it should be an up bar for there to be a long signal here, right? For this 3-bar consolidation to be valid here, but it's an up bar. So what that tells me is I need to take another, or not another, but I can actually take this bar direction and connect that in there. And there we go, and that fixed it, right? So putting a bar direction into, right, the last AND node is, making sure that the signal is in the same direction as the bar, or the bar is in the same direction as the signal, right? So remember, over here we actually had a long signal, but this is a down bar. So putting in that bar direction got rid of that long signal on a down bar. So there, that fixed that. And it actually kind of, well, yeah, you know what, we do need this bar direction here. And let's see if I can find, yeah, here's an example. So look what happened here. Right? Up bar, down bar. Right? So if the pattern starts with an up bar, then the signal is supposed to be a long signal. But it's not. And that, right? So this did not get this short signal didn't get filtered out because we weren't checking the bar direction of the first bar. So, so we need to connect that in there, like so. And if we look, that actually killed everything, right? And the reason why, yeah, let's kind of zoom in here a little bit. So let's disconnect this there, right? So this AND node, right? It's hooked into the comparison solver for the second bar, right? This is the logic to identify the second bar here, right? But this bar direction is for the first bar, right? So if we look at this, if we connect that in, yeah, let's get rid of that, and let's get rid of that. Actually, let's do this. So this bar direction is here to identify the first bar, right? But this AND node is working on identifying the second bar, right? So what we need to do is take the bar direction for the first bar and shift it forward onto the second bar, right? So, right. So remember, let's name this AND node here. So let's call this, right, the number 2 bar, and this other AND node would be the number 3 bar. There we go, right? So this is for the number 1 bar, right? So we need to take, right, this short output and shift it forward onto the second bar, right? Exactly like what we used this look back node for, right? If you remember, this look back node took the signal from the number 2 bar and it shifted it forward onto the number 3 bar, right? That's what this look back node's doing with the displacement function there, right? So, but with the bar direction, we actually don't need to use a look back node. It has essentially what is the same as a displacement function built into it, but it's called start bars ago. So start bars ago, you know, it's programming technicalities here, differences in, you know, in terminology, but the end result that you see on the chart is that the start bars ago does, or, you know, provides the same functionality as a displacement. You know, it's just a matter of what vantage point you're looking at it from, right? So, but they're one and the same. So with the bar direction, you know, you can just change the start bars to go to 1, and effectively it adds a displacement to it, right? And yeah, if we look, so right, this up bar, well, it now has a short output on it, but so the long output from this up bar is now on this down bar, right? So here's the long output. So we can see that the outputs have been shifted forward 1 bar. And so now, once we've done that, now we can connect that in there. And now everything works. Yeah, so there we go. So we got rid of this erroneous short signal there. And if we look at these others, let's see, yeah, this, yep, that looks correct. There we go. Yep, and that looks correct as well. Yes, you know, so we can see we get a bunch of these, you know, kind of consolidations in a row there. So that's basically it. Let's just kind of clean this up a little bit here. And so with this, it just kind of looks like probably some, I don't know, additional filtering might be wanted to go along with this. You know, like, if we go back to the screenshot here, we can see that most of these consolidations have several bars in the same direction as the first bar, right? So we got a bunch of down bars, and then the first bar is a down bar, a bunch of down bars, and the first bar is a down bar. Let's see, this one, yeah, that's an up bar. I think that's an up bar. And then the first bar is an up bar, right? So maybe you want at least 2 bars in the same direction, to in order to identify the first bar. The previous bar needs to be in the same direction, right? So you need 2 bars in the same direction, right, as the first bar. So in other words, right, we would need 2 up bars, right? So for this short here, right, there's no previous down bar. So we could strip this out by saying, okay, you have to have 2 down bars, and here we have 2 down bars, right? All of this might get stripped out as well. So we could do that by this first bar direction solver, right? And we can say number of bars needs to be 2, right? So the first bar actually has to have 2 bars in the same direction to qualify. And actually, yeah, that really kind of cleared things up a lot, didn't it? Yeah. So there we go. That was something simple to add to this, and it does seem to clean it up a little bit. So I guess we'll leave it right there. But if you just want the raw consolidation functionality, then you want to keep the number bars to 1, right? And then that just finds all of these consolidation bars here, right? So that's one thing that can be adjusted, right, is the first bar direction solver. And the other thing that could be adjusted here as well, right, that's variable, is the range, right? The range set by the first bar. So for this example, we just used 5 ticks. So you could go in here and adjust the difference, right? So you could make that smaller or larger, right? And that would be right for this solver. And also for the number 3 bar, right? It also has that 5 ticks variance as well. So obviously that's adjustable. So you could kind of, tweak this system a little bit here as well. All right, and also, let's see, there were some filters to be added as well. So let me take a look at the email again here. That's right. So we'll add some filters here. So we're going to use an HMA and the RSI. Although, you know what? Ed did not give me a level for the RSI. Well, I guess we'll just go with the default 20 then. Yeah. So let me save that. And yeah, so let's add those other indicators on to the board, onto the chart. Okay, so Ed wants to use a 13-period HMA, and the RSI is a 14-period. There we go. Okay, there we go. So let's add the HMA as kind of a trend filter for these signals here. So yeah, we can see that this short will get filtered out because the HMA is sloping upward, right? Yeah. We can see that HMA is sloping upward. So let's go in here, go into our logic board. And since we're going to add some filters here, let's, I'm going to take our first bar direction and knock the number of bars, back down to 1. So that way we get a lot more of these consolidation bars there. Yeah. All right, so we just want to look at the slope of the HMA. So let's go to our solver nodes and grab a slope solver here. And let's name this. So it's the HMA 13. All right, there's the HMA. Adjust the period down to 13. And the HMA only has one slope, so we're good to go there. All right, so there we go. Hold on. What is and oh, okay. Yeah, so it's still stuck on the HMA. So hold on. Let me just do this. So if you ever notice that it doesn't match up right away after you switch out the indicators, then all we need to do is just do a simple reload. And there we go. So now BloodHound grabbed the HMA indicator there. So all right, let's go back. All right, so pretty straightforward here, right? When the HMA is sloping up, we get a long output. And when the HMA is sloping down, we get a short output. So now we can, yeah, so all of these, right, all these consolidation signals here, we can now start filtering them based on the direction of the HMA by connecting that in there. And there we go. All right, pretty straightforward. All right, yep, so far so good. And the next thing is to add the RSI here, and I'll just go with the default of 20. Is it 20? Oh no, it's 30. Okay. Yeah, so the default level for the RSI is 30 there. So yeah. So for an oscillator, since we want this RSI oscillator to be greater than 30 to show us that there's some strength here, we're going to grab a threshold solver. And let's name this. All right, and so we want the RSI to be greater than 30. So, all right, so let's replace the SMA with the RSI. There's the RSI. And yeah, we are just using the default settings here. And the RSI is already selected for us, so we're good to go there. And we want the RSI to be greater than 30. we're going to put that in twice. We're going to put 30 in twice to strip out the fuzzy logic part. And so there we go. So remember, the RSI is a non-directional indicator. So since it's non-directional, you want a long output and a short output together, right? So just a little tip there to remember is for non-directional indicators, you want long and short outputs together when that indicator meets your requirements, right? Meets your conditions. And looks like, wow. So it looks like only a couple of times does the RSI ever get below 30. Well, a few more times. Yeah, so let's see, where was I? There we go. Okay, so we can just take the RSI threshold solver and connect that into the AND node as well. And so there we go. There's our two filters added to this as well. Actually, yeah, the RSI is not included in this screenshot, so all right, we'll just leave it as an RSI 30 level. So there we go. Okay, now we're done.